The International Space Station is the world's premier microgravity laboratory, representing a convergence of science, technology, and human innovation. Research on the station includes Earth, space, physical, and biological sciences, benefiting people off the planet and at home. It also provides a platform to develop technology that drives exploration. Traveling 250 miles above the surface at 5 miles per second and circling the globe every 90 minutes, it is a springboard to NASA's next great leap in exploration beyond low Earth orbit. The station recently passed a major milestone when it marked the 15th year of continuous human presence. Throughout those years, NASA's Ames Research Center in California's Silicon Valley has made substantial contributions to the space station. For example, a water recycling system developed at Ames is being used on station to optimize the use of all water resources on board. Water, an essential requirement for life, is a precious commodity in any space vehicle, especially those designed for long-duration missions. Ames researchers also helped pioneer plant growth experiments to investigate how systems could supply crew members with fresh food and vegetables. Robotic innovations developed at Ames are now part of daily life on station. Spheres are free-flying robots currently testing experiments and technology demonstrations for expanded use on station in the future. They are capable of performing many chores, such as inspections that would be tedious and time-consuming for the astronauts. Our journey to Mars is unfolding right now aboard the station. Robotic vehicles will continue to play a key role as we explore the solar system. In 2014, researchers successfully conducted tests with astronauts on station controlling a K-10 rover in use on the ground at Ames. This was the first time an astronaut operated a vehicle on the surface of a planet from space. The station has proved to be a valuable platform for launching a number of small satellites, or CubeSats. TechEdSat is one example of these satellites developed at Ames and deployed from the station. In this project, NASA cooperated with external companies and college students to develop a low-cost payload. One goal was to demonstrate a potential commercial use of the low Earth orbit environment. Ames has a long legacy of life science research that has made significant contributions to understanding the effects of microgravity on the human body. Before people were living on the station, Ames performed bed rest studies to better understand the long-term effects of fluid shifts on astronauts. Studies were also conducted on the heart and circulatory system to better understand the needs that astronauts would have during long-term exposure to microgravity. The 20G centrifuge at Ames was used to investigate the effects of higher than normal gravity levels on astronauts, especially during re-entry after long periods in space. Research on balance, orientation, and space sickness related to the inner ear was conducted at Ames. Techniques were developed to help mitigate the problems astronauts encounter. Ames developed life science experiments performed directly on the astronauts during multiple shuttle missions. These tests provided information that helped nearly every astronaut who has gone to the space station. Today, Ames continues to develop payloads to expand our understanding of how basic life processes respond to the space environment. Studies include seed germination and plant growth, genomics and changes in stem cells, and the effects of microgravity on fruit flies and rodents. With the past, present, and future contributions of Ames research and results on the International Space Station, NASA continues to show how it's working off the Earth for the Earth.